Hello everyone, welcome back to my channel. I'm glad to introduce myself. I'm Vandana, student of Sri Venkateshwara College of Engineering from the Department of Information Science and Engineering, second semester EHS section. Today in this video, we are going to discuss about the subject chemistry, particularly about the topic corrosion. Let's delve into the concept of corrosion. Definition of corrosion. Corrosion can be defined as the destruction or loss of metal or alloy by the surrounding environment through chemical or electrochemical reactions. Example, rusting of iron, a reddish brown scale formation on iron object. Fe2 plus 2OH give rise to FeOH twice. 4FeOH twice plus O2 plus 2H2O give rise to hydrated ferric oxide, which is in the state. Corrosion mainly differentiated into dry corrosion and wet corrosion. Dry corrosion, which is chemical corrosion. Dry corrosion involves the direct attack of metals by dry gases, mainly through chemical reactions. It occurs by direct attacks of atmospheric gases such as oxygen, hydrogen, sulfide, halogens, and sulfur dioxide on the metal forming oxide layer. Example, the attack of dry air or oxygen on metal to form an oxide layer over the surface. Wet corrosion, which is electrochemical corrosion. Wet corrosion involves reaction in aqueous solution medium. The conducting surface of a metal undergoes an electrochemical reaction with the moisture and oxygen present in the atmosphere. Example, rusting of iron. And wet corrosion is explained on the basis of electrochemical theory. Let's come to the type of corrosion. Differential metal corrosion. Differential metal corrosion occur when two dissimilar metals are in contact with each another and exposed to corrosive conducting medium. The metal with lower electrode potential act as anode, undergo oxidation and gets corroded, and the other metal with higher electrode potential act as cathode, undergo reduction and protected from corrosion. This type of corrosion is known as galvanic corrosion or differential metal corrosion. The rate of corrosion depends mainly on the difference in potential between two metals. Higher the difference, faster is in the rate of corrosion. The reaction may be represented as at anode oxidation reaction takes place, at cathode reduction reaction takes place depending upon the nature of environment. Example, tin coated copper vessel. And another type of corrosion, differential aeration corrosion, when a metal is exposed to different concentration of air or oxygen, part of metal exposed to lower concentration of oxygen becomes anodic and undergoes corrosion, whereas other part of metal exposed to higher concentration of oxygen becomes cathodic and remains unaffected. This kind of corrosion is called as differential aeration corrosion. Example, part of nail inside the wall undergoes corrosion. Here we have anodic and cathodic reaction with iron. At anode, Fe give rise to Fe2 plus 2 electrons. At cathode, 2H2O plus O2 plus 4 electrons give rise to 4OH. Net reaction, Fe2 plus 2 OH give rise to FeOH twice. In differential aeration corrosion, we have waterline corrosion and pitting corrosion. Waterline corrosion, it is observed in steel or iron water tanks partially filled with water. When a steel tank is partially filled with water for a long time, the inner portion of the tank below the waterline is exposed only to dissolved oxygen, whereas the portion above the waterline is exposed to more oxygen. Thus, the portion below the waterline acts as anode and undergoes corrosion. The upper portion acts as cathode and is unaffected. A distinct brown line is formed just below the waterline due to the deposition of rust. Here we have the cell reaction where iron combine to form corrosion product. Example, ships which remains partially immersed in sea water for a long time undergo waterline corrosion. Pitting corrosion. This type of corrosion is observed when dust particle or oil drops deposited over the metal surface. Pitting corrosion is due to metal surface is not homogeneous. External environment is not homogeneous. Crystallography directions are not equal in the reactivity. Environments are not uniform with respect to concentration. Pitting corrosion results when the portion of metal covered by dust which is less radiated becomes anodic and undergoes corrosion and from pit. The remaining area of the metal which is exposed to higher concentration of oxygen becomes cathodic and remains unaffected. Once a small pit is formed, the rate of corrosion increases becomes formation of small anodic area to corrode faster because accepting electrons from the cathodic area increases. Here we have the cell reaction of pitting corrosion. Thank you for watching this video.